We're going to talk about the standard normal curve. Now, we'll start out with this kind of cutesy little thing. You've seen this shape before, right? We called it the Bell distribution. This is actually the standard normal curve. Actually, it's a normal curve. It's not the standard normal curve. We're going to learn about the standard normal curve. That one that you saw there just a moment ago was a little present from a former student of mine who's now teaching at Oakland University. So good for her. Good for her. Now, section 6.1 is going to talk all about the standard normal curve, which is going to have that shape that you saw in the Christmas ornament. You'll also see it on your handout, kind of like this. This is our standard normal curve. And you don't really have to take much in the way of notes because this is on your handout already. But let me hit a few of the highlights here about the standard normal curve. First thing to notice is that it's symmetric. So the left-hand side and the right-hand side of this graph are equal. And in this case, with the standard normal curve, it's symmetric around 0. So to the left of 0, to the right of 0, it's the same. What makes this the standard normal curve is that it has a mean of 0 and a standard deviation of 1. So it has a mean of equal to 0 and a standard deviation equal to 1. Just a reminder, real quick, those have some symbols associated with them. Instead of mean, a lot of times you'll see us write mu. What do we write instead of standard deviation? Does everyone remember the symbol for that? Sigma. Well done. Excellent. Now, in addition to the fact that we've got a mean of 0 and a standard deviation of 1, they're symmetric. The other really big and important fact about the standard normal curve and about any normal curve is that the total area underneath this curve has to be 1. Under the curve equals 1. That's certainly a big thing to know about this. So, okay, that's great. We're going to have to practice with the standard normal curve and get used to finding these areas. Now, in particular, there's a couple ways you can find the areas. One of them is with tables. If you actually had a physical copy of the book, you would get tables that look like this, that are nauseating to look at, and great gobs of fun to try and find areas and probabilities from. You can do that. That's one way you can work with this. But we're going to try and do something a little bit more sophisticated and a little easier on you, and that's work with Google Sheets. So in terms of working with Google Sheets, let me explain how Google Sheets works with areas underneath the normal curve. So this is the normal curve, and this command is given to you on your handout. So if you look here, it's Google Sheets commands, it's norm distribution. This is the general format of that command. You're going to type in an x, a mean, a standard deviation, and then cumulative will always be set to true in this course. Let me demonstrate or diagram what it's going to give you. It's going to give you the area underneath some curve to the left of whatever number you put in. So this is your value of x. You're going to put in something like equals norm distribution of x, and then the mean, and then the standard deviation, and then true. And it's going to give you the area to the left of that value. That's how this is going to work. Now, in this section, in section 6.1, the mean is going to be 0, the standard deviation is going to be 1 for all the curves that we're going to work with in section 6.1. That's going to change when we start working with our non-standard normal curves, but for right now, that's it. All right, so let's put that together and try our first example. We want to find the area to the left of 0.93 under the standard normal curve. You know what, there's one more thing that I want to point out about the normal curve before I move on. Let's use two things together. First of all, that the curve is symmetric around 0, and secondly, the total area is 1. How much of the area has to be to the left of 0, and how much of the area has to be to the right of 0? Somebody said it.
0.5.
Yeah, 0.5, 50%. Half the area is to the left of 0, half the area is to the right of 0. 0.500 and 0.5000 there. So that's good to keep in mind because it helps you recognize if you got an answer that's wrong. So for instance, in this one, example A, since I'm working with the standard normal curve, that means this line down the center is at x equals 0. So my question to you, before we even start playing around with our Google command is, do I expect an area that's greater than 1/2 or less than 1/2 when I'm looking up the area to the left of 0.93? What would you guess?
Right.
So this much here has to be 1/2, and since I've got more than that, I expect an answer more than 0.5. So appreciate your participation here. Let's see if we can't find that from Google Sheets. And let's see, I can get rid of that one. Let's just go to this one. So for example A, we're going to type in equals, like all our Google commands start with, normdist. By the time you get to the D there, it should recognize the command. We're going to type in 0.93, and then the mean, which is 0, standard deviation, which is 1, and then true. So your command should look like that. When you press enter, you should get a probability. I'm guessing it's about 0.7 something maybe. I don't know. No, maybe a little bit more. 0.8238. Yay. So equals norm distribution 0.93. Is everyone able to get that number out of Google Sheets?
I think I typed it wrong. Can you show the command again?
Yeah, absolutely. So there's a command, norm distribution 0.93, comma 0, comma 1, comma true. So, Adel, did you get that one?
Yeah.
Okay. All right, so that's kind of a nice friendly one to start out with. Let's try another one. Kind of the same variety there. And that is, and this is just a number off the top of my head. It's not a number that's on your sheet or something like that. But what if I wanted to try and find the area to the left of, say, 1.65? So, draw it this way first, shade it in. So I want to find the area to the left of 1.65. That's going to be 0. So again, I'm expecting something less or something more than 1/2. So, okay. If you're trying to find the area to the left, that's the way Google Sheets is built, is it's trying to find the area in the left tail. So let's take a look at that one. The only difference between the first one and the second one is this part right here. Instead of 0.93, I'm going to type in 1.65. And then the mean is 0, the standard deviation is 1, and then this is always going to be set to true. This is not like it was with our binomial probabilities where sometimes you would use true and sometimes you would use false. It's always going to be set to true. So you should get about 95%, 0.9505. So we're getting that, 0.9505. Victoria?
For the exam, you said that you will give,
I will give the format of the command. So-
is that gonna be like on a separate sheet or like when you give the
you know-
problem, you'll give the command?
It depends on the way I write the test. I mean, I've done two things. One is that sometimes I give a separate sheet with all the Google commands. And sometimes I'm like, all right, we only need a few, so I'll just put the few right on the test. But one way or another, the format of the commands would be available to you. So what you can expect is something like what I have here. You know, the general description of what this is, something like that. All right, let's move down to the next one, which is find the area to the right of negative 0.87 underneath the standard normal curve. So, okay. So this area here, has anyone picked up on this yet? Bless you. And that is, what's this middle line gonna be here? Where's that gonna cross the axis? It's gonna cross at 0, good. So with that in mind, do I expect a number that's greater than 1/2 or less than 1/2 when I do my calculation? The shaded area, well, this much right here to the right of 0 is gonna be how much area? 1/2. Do I got more than 1/2 or less than 1/2? Has to be more than, because you got 0.5 here plus whatever is here. So I expect something more than 1/2. And the reason I point that out is so that you can be critical of your answers. If you're looking at these areas and going, all right, this is roughly what I expect, then at least you can know if you got the right answer. But let's keep in mind something. How does Google Commands work? It doesn't give me the area to the right of a number. It gives me the area to the left of this number. So if I typed in, I don't know, norm inverse of negative 0.87, comma 0, comma 1, comma true, if I typed it all in, it's not going to give me what I want, at least not initially. Norm distribution, negative 0.87, comma 0, comma 1, comma true. Now you just told me that we expect a number that's, our final answer should be greater than 1/2. And that's clearly less than 1/2. So what's wrong, or what else do I have to do in order to get this probability? Adel? Excellent. So essentially what we got to do is we got to find the complement of this. So what we found is this piece right here, that was our 0.1921. So that's 0.1921. If I want this area, it's going to be 1 minus 0.1921, and that should be 0.8079. Now you can have Google Sheets do that work for you. You don't have to do it in your head or even on a calculator. So, question? Yeah. Yeah, well, yes, the entire shaded area. Because to the right of 0 would be 50%. So, yeah, good question. So I can do it this way. I can do equals 1 minus, and then I'll just click cell for me, which would be A6. And when I press the enter key, I should get the answer that I just put down. So 0.07 or 0.8078. I guess this one rounds to 8. All right, Johnny?
Actually, I typed the formula wrong, but I got the right answer because if the actual line where it is to the left of 0, it's going to be negative. But if you don't put it in as negative, you're going to get the other space.
Yeah, that's it's a nice observation because it's symmetric. So I'm not sure if you want to think of it that way, but you could flip this area around and you could say, all right, well, the area to the right of this would be the same as the area to the left of 0.87. So 0.87 is over here. And finding the area to the left of positive 0.87 is going to actually work out to be the same as the area to the left of negative 0.87. So yeah, nice observation and fortuitous little whoops there that you got the right answer. So cool, very nice. Other comments on example B here? Yeah, you're gonna have to do one of those two things. Either do the subtraction or kind of flip it around so that you make it a problem like Johnny did here and looked at the area to the left of the opposite of that. So one of those two. But wait, there's more. Feel like a commercial, right? There's another kind of circumstance that we're gonna have to deal with. Are we okay with this one here before we move on to another circumstance? Now my goal here is to spend a lot of time on section 6.2 to the point that you're really comfortable getting these numbers and these probabilities. We're going to use these a lot later in the course for our hypothesis test, for our confidence intervals, all kinds of things, and it's all going to come back to our skills right now. So I don't mind spending extra time here getting this stuff right. Imran. Yeah, go ahead. I'll have to look at the syllabus. We'll take care of that after this section, okay? Let's take a look here. I want to find the area between 1.23 and negative 0.97. Well, that's again going to require some thought and some calculation. You can't just look up the area to the left of 1.23 and be done, because I want the area between those. So what kind of cleverness are we going to do to come up with that answer? How is this going to work? Yeah.
Find the left of the 1.23 and then find the left of that one and then minus the left of 0.97 from 123.
Perfect. So we're going to find the area to the left of 1.23 and subtract off the area to the left of 0.97. The difference is going to be that area in between. So when I find the area to the left of this and subtract off the area here, that should leave me with the area in between. So perfect. That's exactly our game plan. Let's go back over to here. This is example C. Equals norm distribution. Norm distribution 1.23, comma 0, comma 1, comma true. Now that's the area to the left of 1.23. Okay. I need to repeat that calculation down here and get the area to the left of negative 0.97. So you can type that in. Quite often what I'll do is I'll just copy that command and then edit it. So if I copy that command and edit it, what's the only change I got to make here?
X.
Yeah. Instead of 1.23, it's going to be negative 0.97. Nice. So I've got these two numbers, but that's not quite enough. Gabby, what do I have to do to finish this one up?
Subtract.
Yeah. So I'll just do this on one more line. Equals this one minus this one. So overall, you should get 0.7246. So 0.8907 minus 0.1600 and 1660 should give me about 0.7246. Yeah, 7246. Awesome. Is everyone managing to get that number? We're all good? How about a thumbs up for my Zoomers? Michal, all right, good deal, thank you. Nate, get that one? All right, good deal. My folks here, Cody, Jackson, all right. All right, looking good. Now let's kind of repeat that example for a couple special numbers here. I want us to try and find the area underneath the normal curve between -1 and 1. And then repeat that between -2 and 2. And finally between -3 and 3. So let's see if we can't find all three of these areas. Now personally, what I'm going to do once I get the first one is I'm just going to copy my commands and then repeat them for these other calculations. So it's the same kind of thing here that we did just a moment ago. It's just this time we've got some different values for our z values. You should see the areas increasing and getting closer and closer to a very special number. So finding the area between -1 and 1 really means finding the area to the left of 1, subtracting off the area to the left of -1. So just like we did just a moment ago. So I'm going to walk around, make sure everyone's getting those areas. If you're not, I'll help you out. My Zoomers, I'll be back in a little bit. If you get the right answers, type them into the chat to me privately. That way, if other people want to try and follow along and try and come up with these numbers, you're not going to spoil the surprise. And if you're watching this later, fast forward until you get past the pause button.
How do you throw this command down here? How do you actually like go in and copy it?
Let's see. So there's a couple things you can do. One of them is you can just copy this cell. Is this a Mac? No.
Yeah.
Yes.
Yeah.
Okay. So command and then paste. And then you just go back up here and you change it. So instead of 1, maybe you want -1. Oops. And we did it.
Very good.
There. Let's edit this. Oh, didn't copy the command. Just copy. Paste. So come up here and make that a -1. And then I want to find the area between those. Right?
Yeah.
So you want to subtract it. So equals the subtract them. And then you can repeat that calculation like a couple times, you get the area between negative 1 and 1, negative 2 and 2, negative 3 and 3. That's clever. Okay, nice. Which one are you doing? Number 1?
This is John.
Okay. Because if you subtract those, you should get about 95%. We did D1 to D6. You need to do D5 to D6.
Oh.
That's what you're doing. Yeah. So, what you can do is you can copy all 3 of these cells, paste them right next to yourself. So, let's see. No, this is okay. Well, you need to subtract the bigger number minus the smaller number.
Okay.
So as long as you did it in that order, it's okay. You're looking at your answer, you must have done it the correct way. So can you highlight all 3 of those cells? Copy that, paste it here, and paste it here again. And now what we want to do is we want to go back here. Negative 2, 2, and we'll below that, and then do negative 3, 3. Okay. Let's see. No. So we're trying to do this one right here. Between negative 1 and 1. And then between negative 2 and 2, negative 3 and 3. We're trying to work on the negative 1 to 1 first. And then we'll do negative 2 and 2, negative 3 and 3. Nice. And the color showing off. Cool. Ready? Alright, so we're gonna do this again, except that we're gonna do it between negative 1 and 1. So like up here.
Alright. Oh, okay.
So that's what we're working on.
Okay.
Subtract these small parts. Your areas should only have to be between 0 and 1. That one looks right, that one looks right. That one, you just gotta subtract it. So if we're trying to find the area between, say, negative 2 and 2, or negative 1 and 1, that's the first one, negative 1 and 1.
Oh,
Oh, no, I'm doing negative 1 and 1, negative 2 and 2, so. Okay, so what's going to go on is going to be kind of like this. See what I got in the above example C? We want to find the areas of the left with 1 minus the areas of the left with negative 1. So we do both of those. And then we'll edit that and come up with 2. So try and tell the areas of the left with 1.
I gotta look at
That's your last one. That's the 3, 3, 3, right? Okay. I got the last one was right.
Yeah, I got the orders mixed up, so I put the, 9.1 first and then instead of the other way around.
Okay.
If you could be my eye, I would maybe stab you through your leg.
Yes, all right, that's between negative 1 and 1. Repeated for negative 2 to 2, negative 3 to 3.
Okay, I almost did the same thing.
All right, all right. Let's see how things are looking. All right, looking good on the chat. Yeah, Jaron, well done. All right, so let's start with finding the area between negative 1 and 1. So that's going to mean two commands. It's going to be finding the area to the left of 1 minus the area to the left of negative 1. So let's do that. And let's see, I'll kind of label it here. So area between negative 1 and 1. And let me give myself a little more room here. All right, so we'll start out with the area to the left of negative 1. So it's going to equal norm distribution, negative 1, comma 1, actually comma 0, comma 1, comma true. So we get that area. I'm just going to copy that and paste that down here. The only change I need to make now that I'm trying to find the upper area is I want the area to the left of positive 1. So I'll change that negative to a positive 1. And then it's suggesting, you know, do you want to do something here? I'm not sure what it's suggesting, but I'm just going to do my own thing. I want to do the area as the difference between these two, and that's going to be B12 minus B11. Let me go with their suggestion just for a minute. If I did that, can anyone see a problem with this number? What's wrong about this that I would flag you on a test immediately? Chloe?
Negative.
It's negative, yeah. Yeah, it has to be positive. All of the areas and probabilities you get from this table have to be positive. Now, it's an easy fix in this case. We just got to subtract them in a different order, B12 minus B11, and that's the right way. Let's continue and do this a couple more times. Now, the beauty about a spreadsheet is that it's good at doing these kind of things again and again. So if I copy this here and make a couple edits, say between negative 2 and 2, then I just got to change here, negative 2, and here, positive 2, and now you see that the area between negative 2 and 2, it's about 95% of the area underneath this curve should be between those two values. Repeating this one last time for 3 standard deviations. This is going to give us what we saw earlier in this course is called the empirical rule. And I'll look back at that with you. 3 and 3, 3, and 3. Now the nice thing about having the Google link that I gave you is that if you fall behind and you wanted to look at my calculations, by the end of today, this sheet will be updated with the fresh calculations. So if you go back and copy this file to your Google Drive after class today, it'll have all the right answers. But here's the ones that I want to flag right there. About 68.27%, 95.45%, and 99.73%. So what's that all referring to? Let's take a look at your handout. And this is something you could have seen if you looked in the book earlier in this course. That's talking about your bell-shaped curve, your normal distribution. Within 1 standard deviation of the mean, you're going to find about 68% of the area. That's what we saw right here. 68% of the area is within 1 standard deviation of the mean. How about if you go out 2 standard deviations away from the mean? That's 95%. And finally, 3 standard deviations away from the mean, that's almost everything. If you're beyond 3 standard deviations away from the mean, wow, you're pretty special. So There's not much area out there. If you're 3 standard deviations away from the mean, that's pretty dramatic. So nice, nice. We're okay with finding these values between 2 points on the standard normal curve. All right, doing good. Thanks for the nods. Let's do a couple more. And let me just scroll down here. I think it's a little easier to see. Maybe I can make this a little bit bigger as well. So the next one, example D, says, assume the readings on thermometers are normally distributed with a mean of 0 and a standard deviation of 1. Find the probability that a random thermometer reads between negative 2.01 and negative 0.92. Draw and sketch the region. Well, you've got 3 regions to choose from. 3 examples here, A, B, or C. Which one looks like what they're asking between negative 2.01 and negative 0.92? C. What's wrong with A? Yeah, it's not just between them. You're also shading to the left of negative 2.01. Might be hard to see on your handout, but over here on the OneNote presentation, then it should be a little bit easier to see that C is the one you want. So C is a lot like, or excuse me, answer C here. Finding the actual value is going to be a lot like our calculation up above. So let's just do that again for example D. So we'll go to our Google Sheets. Let's open up an example D. Now you can do it in one line if you want. My morning class, and perhaps some of you feel comfortable just doing it in 2 and then subtracting, that's okay. But if you wanted to do it in one line, here's how it would look. It'd be norm, dist. Now which one do I got to start with? And which one do I have to subtract? Yeah, so negative 0.92. The bigger one minus a smaller one. So norm distribution of negative 0.92, comma 0, comma 1, comma true, minus, so we're going to do it all in one line here. Norm distribution. Now before I finish typing in this command, do I expect a number that's less than 1/2 or bigger than 1/2? Less. It's to the left. All this area is to the left of the 0, and if I have some portion that's to the left of 0, it's going to have to be something less than 1/2. So let me finish this one off. Norm distribution, negative 2.01, comma 0, comma 1, comma true. So there it is all in one command. In this section, it's a great question. In this section, the mean and standard deviation are always going to be 0 and 1 respectively because we're working with the standard normal curve. But not everything fits the standard normal curve with a mean of 0 and a standard deviation of 1. So I'm glad you asked that. And let me give you a little preview of something to come. So let's see, let me open this up right here. So this is data from the state of Michigan. This is the average monthly temperature for the month of February for the last 128 years. So from 1895 to 2022. So, okay. And if you calculate the mean and standard deviation, which I've done here, then I could fit a normal curve to this, but it's not the standard normal curve because the mean isn't 0 and the standard deviation isn't 1. I'm going to use the mean of this and the standard deviation of this. So I kind of round them a little bit and I get this kind of distribution. Let me make that a little bit easier to see this way. There. So there you go. So the area underneath this curve approximates reasonably this area underneath these histograms. So if I wanted to find the probability that maybe an average temperature is 34 degrees or higher for the month of February, then I could do that underneath this normal curve. I can find that area. So the commands are going to be exactly the same. It's just that instead of putting in the mean is 0, the standard deviation is 1, you're going to put in the mean is about 22.7, the standard deviation is about 5. So that's going to be the only difference. So it's a great question. Let's go back to this one. And I think we finished example D. So, yeah, and your question was, is the mean going to always be 0 and standard deviation always going to be 1? In this section, yes, but once you move beyond that section, no. All right, so another one. This one I want you to do. So this time we want to try and find the area to the right of negative 0.81. Do you expect this area to be less than 1/2 or more than 1/2? More than 1/2. Good. Remember our line down the center here? That's 0. So to the right of 1 or right of 0, that's 1/2. Our area has to be more than that. Now keep in mind that when you type in negative 0.81 on Google Sheets, it's going to give you this area here to the left. Somehow or another, you're going to have to figure out how you want to get the area to the right of negative 0.81. And there's a couple ways you can do it. Give yourself a chance at that. All right. Let's see. Cody, want to volunteer? What are we going to do to get that area?
I'll do 1 minus
Okay, 1 minus.
0.208.
All right, perfect. So we're going to do this in 2 steps. First of all, find the area to the left of negative 0.81. And then we're going to subtract that area from 1. So 1 minus this answer should give you 0.791. Beautiful. All right, so the command that you're going to type in then is going to look like this. You can do it all in one step. You can do equals 1 minus norm distribution of negative 0.81, comma 0, comma 1, comma true. Now I haven't written the exam yet, that's a week from today, but sometimes on the exams, I'll ask you just to write out the command that you type in. It helps me and it helps you because sometimes you'll make a tiny mistake and I can see it like, okay, they got the general idea. Other times I might just say, all right, just give me the answer. So, up to you. All right, I think I'm going to split this up into 2 videos here. That way, each one's not as long. When we come back, we're going to have to figure out what this notation is, z sub alpha. So that's coming our way in a little bit.